Good evening, everyone. Thank you for joining us for this week's session of ACT Prep. Just a few things to talk about before we get started with the lesson tonight. We're kind of winding down the end of the course, and as you know, I'm due to have a baby at the end of the month. So rather than taking a break for a few weeks and finishing up the last few classes, we thought it would be best if we try and get them all done before the end of the month. So there's going to be a little schedule change. We have 5 classes left. So we'll do class tonight, and then we'll do class again Friday at 6 o'clock. Next week it will be Wednesday and Friday at 6 o'clock. And then the last class will be May 27th, which is a Tuesday at 6 o'clock. We will post all of this on the website so you know. And if you have any questions, of course, please feel free to email me. This way we can make sure we get everything in, hopefully before the baby arrives. And if that comes sooner, we will post something and let you know when the rest of the classes will be. So now we will get started with some math. Today we're going to be talking about arithmetic review and algebra review, which are 2 things that will be on that math portion of the ACT. And then we will talk about the practice questions that you did from last week on the ACT website. Okay, so we will get started with some arithmetic review. Okay, so arithmetic review. For problems that involve several different operations, one thing we want to always remember is order of operations rule, or PEMDAS, or please excuse my dear Aunt Sally. You might have learned it a few different ways in math class. So the PEMDAS stands for parentheses, which is what you would do first. Then you do exponents, multiplication, division, addition, and then subtraction. Now, the multiplication and division and the addition and subtraction, you always do in order from left to right. So if subtraction is before addition, to the left of it, you would do that first. So you do the multiplication and division first from left to right, and then addition and subtraction from left to right. So PEMDAS, or please excuse my dear Aunt Sally. There may be a few of these problems on the ACT in which you have a few different operations going on. So you just always want to remember, and usually that's part of one step of a larger problem. So you just always want to remember your order of operations when dealing with exponents, when dealing with parentheses, that sort of thing. A fraction is another way of expressing division. So the expression 1/2 just means 1 divided by 2. A fraction is made up of the numerator, which is on top, and the denominator, which is on the bottom. You can also think of a fraction as a part over a whole. So 1/2 would be 1 part over the whole, which is 2 parts. So a few things we want to remember about fractions. And again, fractions, you know, it's a pretty basic thing that you probably learned, obviously, a long time ago in math class. A lot of the ACT problems are not going to be just fractions, but fractions will be involved in a larger problem with several steps. So you still always want to remember the rules when dealing with fractions. So the first thing we want to talk about is when comparing fractions, you need to find a common denominator. You cannot compare 1/2 to 1/4. They need to be both, you know, a 4 in the denominator or a 2 in the denominator. So to keep the entire fraction the same, however, you need to multiply the numerator by the same number. So if we change the denominator, we always have to change the numerator too. So once you have done this, you can compare the numerators, which is bigger or smaller. So for instance, if we have 1/2 and 1/4, we want to compare them. We want the denominators to be the same. So let's make both denominators 4. So we keep the 1/4 the same, but we multiply the bottom of that 1/2 by 2, right, to get it to be 4. So then we need to do that to the top. That would be 2. So now we have 2/4 compared to 1/4. And we obviously can tell then that the 2/4 is bigger than the 1/4. So if we change the denominator, we always have to change the numerator as well. And once the denominators are the same, we can compare. So to add or subtract fractions, we must again find a common denominator. You cannot do 1/2 minus 1/4 or 1/2 plus 1/4. They have to have the same denominator. So again, you would just change the denominator and then you'd have to change the numerator as well. To multiply fractions, it's much easier. You just line them up and multiply across the top and multiply across the bottom. So multiplying fractions is a little easier. When we divide fractions, we just invert the second fraction and multiply. So invert means to flip. So I tell my students, think skip, skip the first fraction, change the division sign to a multiplication sign, and then flip that second fraction. So when we're dividing fractions, think skip, change, flip. That's what you have to do. And then you just multiply across, and it's easier. So fraction can be written as a decimal as well. A few rules that we want to remember about decimals. To add or subtract decimals, we want to line up the decimal points and then proceed as if it were a regular addition or subtraction problem. So you can do it as long as the decimal points line up. Then you would just, like it's, you know, an addition problem with several numbers, subtraction problem with several numbers. Just want to make sure those decimal points line up. Again, a lot of this is review from way back when, but sometimes when you don't use it for a while, you forget it. So sometimes the math that you've had a long time ago ends up being the tricky math on the ACT. Oops, did we skip one here? Let's see. There we go. So to multiply a decimal, you want to ignore the decimal and then just multiply the numbers like you would normally. When you are done, count all the numbers to the right of the numbers you just multiplied. Then place the decimal point in your answer so that there are that many numbers to the right of it. So if there's 2 numbers and then 1 number with both numbers added together to the right of the decimal point, that's 3, then you move the decimal point 3 places from the right. So you just ignore the decimal point at first, multiply like it's a normal number, and then count how many numbers you have to the right of the decimal point total, and then add those. That's how many spaces you're going to go with your decimal point from the right. Let's see here. Okay, a ratio compares a part of something to another part of something, not to be confused with a fraction, which compares the part to a whole. So a ratio is a little different than a fraction. A fraction is a part to a whole. A ratio compares a part of something to another part of something. In other words, a ratio of boys to girls in a class. Maybe there's 20 kids in the class, there's 11 boys, 9 girls. So the ratio of boys to girls is 11 to 9, part to a part. The fraction would be of boys in the class would be 11 over 20, the part to the whole. A percentage is a fraction where the denominator equals 100. So 60% of something is the same as 60 over 100. A few percentages that you should just be familiar with, just because it saves you time on the ACT. 1/2, 50%. That's probably something everybody would know, but just good to be familiar with. 1/4 is 25%. 1/5 is 20%, and 1/3 is 33%. Again, you don't have to know those, but they just might save you a little bit of time on the test rather than plugging it into a calculator if you just know it off the top of your head. So again, a percentage is a fraction where the denominator is 100. Okay, so mean, median, and mode, something again that you will have learned a while back, but good to refresh your memory. The mean of something is just another way of saying average. And you know we get the average by adding up all the numbers and then dividing by the total units that you have, the total numbers that you have. So if you have 3 numbers, 2, 3, and 4, you add 2 plus 3 plus 4 and then divide by 3. So that's the average, the mean. The median is the middle number when lined up in order. So if you are asked the median of a group of numbers, you need to make sure they're lined up in order. And then the number that's in the middle is the median. Sometimes it might be 2 numbers in the middle. The mode is the number that appears the most. So mode, most. That's kind of an easy way to remember it. And again, it helps, I think, if you line up the numbers in order, because then you'll be able to see how many of each number there is in a set of numbers. And again, there could be more than one mode. If there's, in a group of numbers, 3 5s and 3 7s, and those appear the most, then the mode would be 5 and 7. Combination problems will ask how many different ways things can be combined or chosen. The number of combinations is the product of numbers of things, of each type of thing you can choose from. So all you would do for a combination problem, usually you multiply. So if there's 2 hats to choose from, 3 shirts to choose from, 2 pairs of pants to choose from, 2 times 3 times 2. Another way to do this is to do a tree diagram, but that obviously takes more time. And since you want to save time on the ACT, it's good just to know you want to multiply 2 times 3 times 2 to find the different combinations you can do. Okay, so we'll move on to a little bit of algebra. Now, for algebra on the ACT, they're doing elementary algebra, pre-algebra, and then algebra. So there's different types of algebra problems, from the most basic to higher level algebra problems. All algebra means is to solve for an unknown quantity, and usually we think of something like x or y, but it's usually represented by some sort of variable, and they'll ask you to solve for it. So just remember, when solving for the unknown variable, whatever you do to one side of an equation, you must do to the other side. That's the golden rule of algebra. So if you do something to one side of the equal sign, you have to do the same thing to the other side. One way to solve algebra problems on the ACT is to plug in numbers from your answer choices. Obviously, again, this is going to take more time, but if you just aren't really sure what to do, you have 5 answer choices in front of you, and one of them is a correct answer. So you can always plug in answer choices for x or y or whatever the variable is and see if any of them work to solve the problem. If you do this, you want to start in the middle with C, because the answers for the math are usually written in order from least to greatest. So if you start in the middle and your answer is too large, you know you can go to the next smaller choice. If it's too big, you can work the other way. So when you do plug in numbers, it's just a good idea to start in the middle, and that'll tell you what direction to go in. Again, this takes more time, so I wouldn't recommend doing this for every algebra problem. But if you are stuck, it is one way to solve for a variable, is by plugging in the answer choices that they give you. So that's one of the benefits of having a multiple choice test, I guess, is the answer is there. You just have to find which one it is. Okay, so here are some math terms that you should know for the algebra portion of the ACT. If something says is, it just means equals. So if they say something plus something is something, that just means it equals. Of, or product, or times, those words mean multiplication. So the product of 3 and 5, 3 times 5, those all mean to multiply. A certain number just means any variable. It could be x or y or z. So sometimes they might not give you the variable. They'll just say a certain number, and you can plug in your own variable, and it does not matter what letter you choose, just as long as you know what you're using. Percent just means over 100. So if you see percent in a word problem, you can always write it over 100. More than or increased by means to add. That means addition. And then less than and decreased by means subtraction. So if they say x is 3 more than y, you know, that means to add. Add 3 to x. X is 3 less than y, subtract. Many ACT problems will involve some sort of factoring. So factoring just is usually in the form of a quadratic equation. And that's one with 3 terms set equal to 0. And you usually see it x squared plus 2x minus 5 equals 0. I don't know if that's a real solvable quadratic equation. I just pulled that off the top of my head, but that's what the form would be. So it would be a variable squared, 2x squared, or just x squared, plus or minus a number with a variable, 3x, and then plus or minus just a number without a variable, set equal to 0. So that's one of the most common types that you will see on the ACT. To factor a quadratic equation, we need to FOIL. FOIL, remember, means first, outside, inside, last. So that's the order you're going to do. So when you have your two sets of parentheses, you want to do the first numbers in each set of parentheses, multiply them, then multiply the outside numbers, then the inside numbers, and then the last numbers. Quadratics usually have two variables that solve the problems, and these solutions are called the roots. So usually when you solve a quadratic equation, there's going to be two values. Sometimes one is positive, sometimes one is negative, sometimes they're both negative, sometimes they're both positive, but usually there's two solutions, two roots. Inequalities are solved the same way as equalities, except when you multiply or divide both sides of an inequality by a negative number, you have to switch the direction of the inequality sign. So greater than becomes less than and vice versa. So that's the thing to remember about inequalities. Other than that, you solve them the same exact way as equalities as you would the other type of equation. Okay, so we'll stop there for now for geometry review. We'll save that for Friday. What we can do now is go to our ACT website page and we'll go through the problems that you guys did for this week. So we did set 1 and set 2. So let me pull those up here. Okay. And you probably noticed that obviously this is a range. I know we didn't do geometry or even a little bit of trig yet. We'll do those on Friday. This was obviously a mix of all different types of math problems, but I didn't think any of these were overly difficult. They were pretty fair math problems, pretty basic, and this is what you will see on the ACT. So we'll talk a little bit too about whether it's an easy problem or a hard problem, because remember I said last week, the easier problems will just have 1 or 2 steps. The more difficult problems are not necessarily more difficult as far as the math skills go, they just might have more steps to them. And those are the problems that get a little tricky because it's easier to make a mistake, it's easier to miss what the problem is really asking you to do. So those math problems that have more than one step, you just really want to make sure you know what the problem's asking you to do. Okay, so scroll down here. Well, first let's look at the directions and what they tell you at the top. This is always the same, so we can go over it now and then you won't have to read it on the ACT because it will be the same. But they're telling you to solve each problem, choose the correct answer, and then fill in the corresponding oval. Okay, that's the same. Do not linger over problems that take too much time. Solve as many as you can, then return to the others in the time you have left in the test. So unlike the reading portion that we just did last week, and I said don't skip them and come back at the end because you will have read other passages, you might get confused. With the math, you definitely can do that. If it's something that you think you can solve, but maybe it might take you more time, circle it, put a star next to it, come back to it. The math, they're all, you know, they don't go in any particular order, so you don't have to do them in order like you do the reading passages. Just again, a reminder that if you do skip problems, make sure you skip the oval on the answer sheet too so you don't get all the answers one problem off because that could be problematic. Also, if it's a problem that you look at and you just think there's no way I can answer this, skip or put an answer down, take a guess. Don't worry about coming back to it. There will be those problems on all of the sections of the ACT, and I know it goes against our grain to just take a guess. Your teachers always tell you, don't just guess, but on the ACT, if you know there's no way you're going to be able to solve it, do not waste time on it, but don't leave it blank because you're not penalized for a wrong answer. So better to take a guess and have a chance of getting a point than leaving it blank. Okay. So it says you are permitted to use a calculator on the test. You may use your calculator for any problems you choose. Some of the problems may best be done without using a calculator. You might be able to do some without a calculator. I would not recommend doing that many without a calculator because again, saves you time and it helps you lower your risk of making a mistake. But some of them you might just be able to do in your head real quick, and that will save you time rather than plugging in numbers in your calculator. So make sure you have your calculator that works, you know how to use it, and I would recommend using it on as many problems as you can. But again, there's going to be a few, you know, if it says something which is not a prime number, obviously that you don't need a calculator for. So there will be a few that you don't need your calculator. Okay, now looking over at the other side of the directions, it says, unless otherwise stated, all of the following should be assumed. So these are just some rules that they're telling you just to look out for. Illustrative figures are not necessarily drawn to scale. So that means you can't just take a guess by looking at two triangles or a trapezoid or something like that. It might not, you know, it will look like it is, and they usually are, but they don't always want you to assume that. Geometric figures lie in a plane. The word line indicates a straight line, and the word average indicates the mean, the arithmetic mean. So we just talked about that. Average is a mean. So those are just some things that they just want you to know. Unlike the SAT that we talked about last week, you will not get any formulas, but you really don't need any formulas to be successful on this. I mean, you should know the formulas, but you don't need them in the beginning like the SAT provides. So that's not a big issue and it won't hurt you. Okay, so that being said, let's start looking at the problems. So the first question is just kind of a straightforward, you know, that how many miles per gallon, how many gallons, that type of question. And you've probably seen it before in math tests, and it definitely will show up some sort of question like this on the ACT. So just ask you, a car averages 27 miles per gallon. If gas costs $4.04 per gallon, which of the following is closest to how much the gas would cost for this car to travel 2,727 typical miles? So all we're going to do here is first we want to find out how many gallons are we going to use of gas if we drive this trip. So what we want to do first is divide how many miles we drove to 2,727 miles divided by 27 because that's how many miles per gallon. When we do that, we get 101. So now we know we're driving, or we're going to use 101 gallons of gas. So each gallon costs $4.04. So our next step will be to multiply 101 by $4.04. And when we do that, we get answer D, $408.04. So that's a lot of money for gas. But that was a two-step problem, okay? First, we want to divide. We want to find out how many gallons we're going to use. And then the next step is how much is that going to cost us? Okay. And at any point, please ask, you know, if you have a question on any of these, please feel free to ask the question live, or you can always email me later. Okay, the next question is a pretty straightforward algebra question. So they say when x is 3 and y is 5, how much does the value of 3x squared minus 2y exceed the value of 2x squared minus 3y? So a few things we want to know here. Exceed means how much more, right? So they're saying how much more is 3x squared minus 2y than 2x squared minus 3y? So the first thing we want to do is plug in some numbers. So they tell us what x is and what y is. So we're just going to plug in 3 for x and 5 for y. And then that's going to give us 3 times 3 squared minus 2 times 5. And when we do that and work that out, that gives us 17. Then we're going to do the same thing. Plug in 3 and 5. So then we get 2 times 3 squared minus 3 times 5. That gives us 18 minus 5, and that equals 3. So now we have 17 and 3. So our last step here is how much more is 17 than 3? Let me just subtract, right? Find the difference. And then 17 minus 3 would give us 14. So the answer there is G, 14. Okay, the next question, what is the value of x when 2x plus 3 equals 3x minus 4? Again, a pretty straightforward algebra question. Some of these, they're nice, these questions that don't have a lot of reading to them. These big, the big word problems are the ones that take up a little bit more time because you have to obviously read more and usually they require more steps. So these last few have just been pretty straightforward algebra questions, which is nice. So 3, we're just going to solve for x, okay? Just asks us to solve for x. So what we want to do, we have 2x plus 3 equals 3x minus 4. So we want to get all of our numbers without variables to one side and then all of our numbers with the variable to the other side. So remember the golden rule, whatever you do to one side, you do to the other. And you don't have to, but it's obviously much easier if you keep everything in positive numbers rather than negative numbers. So what we can do first when we set this up is add 4 to both sides. That will cancel out the negative 4 or the minus 4 on the one side. So when we do that, then we get 2x plus 7, because we added that 4 to the 3, equals 3x. And then we got rid of that negative 4 because those canceled out. So now let's move that 2x over to the other side of the equal sign. We'll subtract 2x from both sides. That leaves us with 7 on one side of the equal sign, and then 3x minus 2x is just x. And there's our answer, 7 equals x, and that's all they're asking us to do. So the answer for that one is E7. Okay. What is the greatest common factor of 42, 126, and 210? The easiest way to do this, I think, you can go and do all the factor all these numbers, but I think the easiest way is just to plug in numbers right now. And obviously they're asking the greatest common factor. And remember, factor means a number that can be divided into all three of those numbers evenly. Start with the biggest number. See if that works. Excuse me. So let's just start with 42. Let's divide 42, 126, and 210 by 42. And actually, this is great because when we do this, 42 divides into all of those evenly, and you can stop right there because that's your biggest answer choice, and it works. So the answer there is 42. If 42 didn't work, then I would go down to J and do 21 and see if that worked, and then work your way backwards. But since they're asking for the greatest common factor, the biggest number, start with the biggest number and see if that one works. And lucky for us, for this one, it did. So, so that was a quick problem. But for something like that, plugging in numbers, I think, is the easiest way to go. And just plug them into your calculator, divide each of those numbers by your answer choices, see which one works out. Okay, 5. It's going to be a little bit longer. It's a word problem. So it says sales for your business were $3 million more the second year than the first, and sales for the third year were double the sales for the second year. If sales for the third year were $38 million, what were sales in millions of dollars for the first year? So it sounds like a lot. There's a lot of words in there, a lot of millions and years. This is actually another algebra problem. And we're going to do let statements for this one. I like to tell my students to just write let statements out right away. It kind of helps you map everything out, see what you have, and then solve it as an algebra problem. So we're going to say let x equal the first year. Then for the second year, we're going to say let x plus 3 equal the second year. And I just did 3 because we're talking in millions of dollars, so everything's going to be in millions of dollars. So we don't need to put 3 million. We can just put 3. So they're saying the second year was 3 million more than the first. So x is going to equal our first year. 3 million more means to add, will be x plus 3. Then sales for the third year, it says it's double that of the second year. So the second year was x plus 3. So to double that, we're just going to multiply the whole thing by 2. So we're going to have 2 times x plus 3. That's going to be our third year. So we have x is our first year, x plus 3 is our second year, and 2 times x plus 3 is our third year. So now we have our 3 years written down in algebra form, I guess you can say. So now they're saying if sales for the third year were $38 million, what were sales in millions of dollars for the first year? So we have our third year is 2 times x plus 3. We're just going to set that equal to 38. Remember, we're keeping everything in millions of dollars. We don't need to write out 38 million. Just write 38. So we can just put 2 times x plus 3 equals 38. And then we'll just solve for x. So when we do that, we have 2x plus 6. When we carry out our 2 equals 38. Subtract the 6 over, 2 equals 32, x equals 16. And there's our answer, because they just wanted us to find the first year. And remember, the first year was just x. So all we're doing is solving for x. When we work that out as an algebra problem, we have x equals 16. So our answer there will be A. So let statements, they're great because they just map everything out for you and make it much easier to see what you're dealing with and put it in an algebraic form, an equation. Okay, now we have a little bit of geometry, which we haven't talked about yet. But again, this is all stuff that you probably would have had by end of sophomore, beginning of junior year. So you probably had this already in school, but we will go over it on Friday. So it says in the figure below, ray EF was constructed starting from rays ED and EG. By using a compass, D and G were marked equidistant from E on rays ED and EG. The compass was then used to locate a point F, distant from E, so that F is equidistant from D and G. For all constructions defined in the above steps, the measures of angles DEF and GEF, and then it gives us some choices. So it tells us all this information about these angles, and then it asks us, what are these two angles? And the answer for 6 is F. And the reason why we can say they're equal is because of side, side, side. I think you remember probably side, angle, side, 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 side. Those will tell you if triangles are equal, therefore the angles are equal. And if we take all this information that they gave us, we would see that DEF is congruent to GEF because of side, side, side. So we can say that they're equal. We really cannot say anything about H, J, and K because it doesn't give us any angle amounts. So we don't know what the angles are. And again, you can't assume, even if it looks like a right angle, you can't assume it's 90 degrees because it said in the beginning, not everything is always drawn to scale. It can help you out a little bit, but you can't just assume that. So they give us no angle amounts. We really can eliminate H, J, and K for that. Okay, number 7, abandoned mines frequently fill with water. Before an abandoned mine can be reopened, the water must be pumped out. The size of the pump required depends on the depth of the mine. If pumping out a mine that is d feet deep requires a pump that pumps a minimum of d squared over 25 plus 4d minus 250 gallons per minute, pumping out a mine that is 150 deep would require a pump that pumps a minimum of how many gallons per minute? So this is a lot of reading for a kind of a basic math problem. They give you all this information. They make you take a few minutes and read this whole problem. But really what we want to do is plug in 150 for D and then solve. So that's all they're asking us to do. They're saying pumping out a mine that is D feet deep requires a pump that does this equation. And then they tell you how deep it is, 150 feet deep. So we're just going to plug in 150 for D and solve. And when we do that, we get the answer D, 1,250. So all that is asking us to do, all the words there, that long problem is just really saying, plug in 150 for D and solve. And that's what we do, and we get answer D. Okay. Question 8 says the length in inches of a box is 3 inches less than twice its width in inches. Which of the following gives the length L inches in terms of width W inches of the box? So here we're not solving for anything. They're just asking us to write down the equation of what they gave us. So again, we're going to do let statements. I love let statements. Makes it very easy to set up an equation. So we're going to say let x equal the width, and then they tell us the length is 3 less than twice the width. So twice the width, if we say x is the width, we'll say 2x, and then 3 less is minus 3. So the length is going to be 2x minus 3. And then the answer there is K. Length is 2W minus 3. So all we did there is say, let x equal W, and then the length, 2 times the width, 2x minus 3. 3 less than 2 times the width. So they're just asking us to set up the equation there. Don't need to solve, so we can stop there. Question 9, as in quadrilateral PQRS below, sides PS and QR are parallel for what value of x? So this is actually one of those problems where we know that they're parallel because they tell us. So we're going to look at it as two parallel lines cut by a transversal. And if you remember those rules, there are certain rules that tell you they either add up to 180 or they're equal. And since they're going to be on the same line as the transversal, they're going to add up to 180. So if the angle there at P is 70, the other angle is going to be 180 minus 70, which would be 110. So the answer there is D. So they tell us it's parallel, so we're going to treat them like two lines cut by a transversal, which would be PQ, cutting through there. They're on the same side, so there they add up to 180. Okay, question 10. Obviously, this is one of those problems that you don't need to use your calculator for. How many irrational numbers are there between 1 and 6? And the answer is infinitely many. Irrational. We're not talking about rational numbers. So irrational means decimal points that go on forever. And so there's tons of them that can go on forever between 1 and 6. So the answer there would be K. 11. Again, this is a longer word problem to read. The math problem itself is actually pretty easy, so let's just read through it quickly. A typical high school student consumes 67.5 pounds of sugar per year. As part of a new nutrition plan, each member of a track team plans to lower the sugar he or she consumes by at least 20% for the coming year. Assuming each track member had consumed sugar at the level of a typical high school student and will adhere to the plan for the coming year, what is the maximum number of pounds of sugar to be consumed by each track team member in the coming year? So again, it's probably going to take you longer to read this problem than to do the math for this problem, but unfortunately you do need to read the whole problem so you know exactly what it's asking you to solve for. So here we're just going to do a percentage problem. So it's 67.5 pounds of sugar, and they need to lower that sugar by 20%. So there's two ways you can do it. You can either say they need to lower it by 20%, so they need to eat 80% of 67.5, and we can do 67.5 times 80, or times 80%, so 0.8. Or we can do 20%, 67.5 times 20%, solve for that, and then subtract that from 67.5. So either way, when we do that, we get the answer 54. So that's how many pounds of sugar they will be consuming. So you can either multiply it by 0.8 or multiply it by 0.2 and then subtract that amount from the total. Either way will get you the same answer. So that was just a straightforward percentage problem, but it was a lot of reading for a word problem. Fortunately, those are going to be on there. Okay, last question, and this is obviously a coordinate geometry question. You can see the graph right there. So it says in the standard XY coordinate plane below, 3 of the vertices of a rectangle are shown. Which of the following is the fourth vertex of a rectangle? So they're telling us that these 4 points should make a rectangle. And what we want to do is we're going to look at 2, 1, and then -1, -1, and say how much did it move from that point to that point? It moves 3 units to the left and then 2 down. So we want to do that same thing from point 6, -5. Move 3 units to the left and 2 down, and that will give us that last vertice, which ends up being 3, -7. So the answer for that one is F. Okay, so we will, if there's no questions on those questions, we'll move on to set 2. Here, scroll up. Okay, so again, the directions at the top will be the exact same. So just kind of familiarize yourself with that, and then when you actually take the ACT, you don't have to read the directions. You can skip over that because they'll always say the same thing. So let's go on to question 1 for set 2. Okay, So it says, the lead of a screw is the distance that a screw advances in a straight line when that screw is turned one complete turn. If a screw is 2.5 inches long and has a lead of 1/8 of an inch, how many complete turns would get it all the way into the piece of wood? So what we want to do here is first divide 2.5 inches by 1/8 of an inch. And we're going to do that skip, change, flip that I talked about. So keep the 2.5, although I think it's easier now if we make it 5/2. That way we're just dealing with fractions, not mixed numbers. So let's change that 2.5 to 5/2 or 5/2. Change the division sign to multiplication sign, and then flip our last fraction. So we'll make that 8/1. So now we have 5/2 times 8/1. Just multiply that across, and we get 20. So the answer there is D, 20. Okay, 2, if xy equals 144, x plus y equals 30, and x is greater than y, what is the value of x minus y? So this is actually, it looks like a straightforward problem. There's no words or anything. It's not a big word problem, but there's several steps here because they give us several different equations here. So we know the xy is 144. That just means x times y. We know x plus y is 30. So let's say if x plus y is 30, let's solve for y right now. We'll say y is 30 minus x, okay? Because we know when they are added together, they're 30. So 30 minus x, take away x, would give us y. So we'll say y equals 30 minus x. Now we know what y is, so let's plug that in to our first equation, x times y equals 44. So instead of putting that y there, we'll say 30 minus x times x is 144. Now we can solve because we only have one variable. We're only dealing with x. You can't solve when you're dealing with an x and a y. So now that we just have one variable, we can solve for x. So we have 30 minus x times x is 144. So we can say 30 times x minus x squared. So when I distributed the x, that's what I got, equals 144. So let's move that 144 over to the other side of the equal sign, set it equal to 0, and then we're going to factor. So see what I mean? This has a lot of different steps actually for looking like a pretty basic problem. So we can do x squared minus 30x. Instead of bringing the 144 over, we want to keep that x squared positive, just make our life easier. So let's move everything over to the other equal sign, or the other side of the equal sign. So we'll have x squared minus 30x plus 144 equals 0. And then we're going to factor that. We're going to do our two sets of parentheses. Then we'll have x and x. And then we need to find our two factors of 144. That will give us, that will add up to 30. So you can kind of think, okay, I know 12 goes into 144. So what's something else that might go into 144? And that made me think of 24. 24 does go into 144 6 times. Those are our two numbers we're going to use. So we can have x minus 24 and x minus 6 equals 0. And then when we solve for x, it gives us 24 and 6. Now it tells us that x is greater than y. So x has to be 24, and then y is going to be 6. Now we have to do our final step, and that is find x minus y. So if x is 24 and y is 6, then we just subtract those and we get 18. So the answer there is H, 18. So that actually had quite a few steps to it. They're not hard steps, but that problem would take you a few minutes. So it looks like a pretty basic one. So I guess the lesson here is don't judge a problem by its cover. If it looks like a really big long word problem like that one we did a few problems ago and it ended up being very simple, you know, don't freak out. And if you see one that looks pretty basic, sometimes it might take you a few more steps. Take your time. Okay, number 3. Which of the following is the sine of angle A in the right triangle below? So here's a little bit of trig. There's only going to be a few trig problems on the ACT, and most of them will deal with SOHCAHTOA. And if you can't remember SOHCAHTOA, SOHCAHTOA. We'll go over this next week, but sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So here they're asking us for sine, so it's going to be opposite over a hypotenuse, which is just 12 over 13. And that's answer C. Okay, 4 says Ding's Diner, interesting name, advertise this daily lunch special. Choose one item from each column, only $4.95. Thus, each daily lunch special consists of a salad, a soup, a sandwich, and a drink. And then they give the choices there. How many different daily lunch specials are possible? So we're just, how many combinations can you make from these choices here? We're just going to multiply how many salad choices times how many soup choices times how many sandwich choices times how many drink choices. So it's going to be 3 times 2 times 5 times 4. And when we multiply those, we get 120. That's all we have to do. So that's 120 choices. Answer J. Number 5 says the volume V of the right circular cone with a radius r and a height of h shown below can be found using the formula volume equals 1/3 pi r squared times height. The cone-shaped paper cup has a volume of 142 centimeters and a height of 8.5 centimeters. What is the radius to the nearest centimeter of the paper cup? So again, this problem is just a simple plug in the numbers that they give you to the formula problem. So what we want to do here is plug in 120 or 142 for volume, for V, and then we're going to plug in 8.5 for H, for our height. And we're just going to work through that. Now, this is definitely one where you're going to need your calculator because you have pi there. You have to take the square root because we're finding the radius, and it tells you the radius squared. So you just want to plug in those two numbers. So you have 142 equals 1/3 pi r squared times 8.5. So once you work through that using your calculator, you end up getting a radius of 4. So all that problem is asking you to do is plug in those two numbers into the formula that they give you and solve for r. Okay? Okay, so number 6. A boat departs Port Isabel, Texas, traveling to an oil rig. The oil rig is located 9 miles east and 12 miles north of the boat's departure point. How many miles is the oil rig from the departure point? So this is actually a geometry problem. And when you see something like this, I always tell my students the first thing you want to do is draw a diagram. It does not give you a diagram, but this ends up being a triangle, and then you can solve easily for a triangle. So they're telling you 9 miles east, so we'll draw the base 9 miles east, so that's 9, and then 12 miles north, that's going to be our height, 12. So we have 9 for the base, 12 for the height, and then they want to know how many miles from the oil rig to the departure point. Draw the diagonal, and that's our hypotenuse. So this ends up being a right triangle, and we can plug in our answers using our triangle formula, the Pythagorean theorem. So it's just going to be 9 squared plus 12 squared equals x squared. And when we solve for that, 81 plus 144, it gives us 225, and the square root of that is 15. So the hypotenuse is 15. So when you actually draw this out, it turns into a right triangle, and right triangles are pretty easy. So it looks a little tricky, but if you draw it out like that, you say, oh, I know, this is a right triangle, and they're not going to try and trick you. They just want you to realize what that is. How would you solve for the hypotenuse? Use the Pythagorean theorem. Okay, in the figure below, angle ABC is congruent to DFE. BAC is congruent to FDE. D and F are on AB, AD, and AD is congruent to FB. The distances in centimeters are as shown. What is the length of AD in centimeters? So all they're asking us here, what all that information tells us is that these two triangles here are similar triangles. So we can set up ratios to help us solve. So we have 6 over 12 is equal to x over 20. Okay, so the side of one over the side of other is equal to the same side of the bigger one over the same side of the other side of the bigger one. So when we do that, we have 6 over 12 is equal to x over 20. So we're just going to solve for x, and when we do that, we get x equals 10. Now, that whole side, b to a, then is going to be 10. They tell us that it's equal distance between dA and and BF. And they just want to know what is the length of AD. So what we're going to do is 10 minus 6, we're going to take out that middle part, and that leaves us 4. So BF plus DA is going to add up to 4, and they're the same size. So 4 divided by 2 is 2. So that DA part of that line is going to be 2. Answer D. Which of the following is a factor of the polynomial 2x squared minus 3x equals 5? So we're just going to factor that polynomial. And when we do that, we get 2 answers. And we have 2x minus 5 equals 0 and x plus 1 equals 0. So we're going to look at our answer choices. And H is one of the answer choices that they give us, 2x minus 5. So that's going to be our answer. So we're just factoring there. 9 asks us, what is x, the second term in the geometric series, 1/4 plus x plus 136 plus 108? And then it tells us the geometric series, in the geometric series, the ratio of any term in the following term is constant. So that just means that it's a pattern. That's all that's telling us. So let's look at the pattern. It goes from 4 to something else to 36 to 108. And what we're doing there is we're multiplying the denominator by 3 each time. So to get from 4 to x, we're going to multiply by 3. It's going to give us 12. Then 12 times 3 is 36. 36 times 3 is 108. So x would be 112c. So you're just trying to find the pattern there. That's the only thing you're doing in that problem. Okay, last 3. What is the slope of any line parallel to the line 9x plus 4y equals 7? So the first thing we want to do when we see slope is set that up as an equation of a line. An equation of a line is always y equals mx plus b. Okay, so we're going to put that down, and then we're going to look at what they give us and put it in that order. So we'll have y, 4y, equals negative 9x, because we moved that to the other side of the equal sign, plus 7. Okay, because we moved that to the other side of the equal sign. So when we move our terms around to get y equals mx plus b, what we end up getting is 4y equals negative 9x plus 7. Now let's get rid of the 4, so we have y by itself. We'll just have negative 9 divided by 4, because we're dividing everything by 4. Whatever you do to one side, you do to the other, plus 7 over 4. So our slope is m, right? When we have y equals mx plus b, that m is the slope of the line. So parallel lines have the same slope. So if this line has a slope of negative 9 over 4, the parallel line would have the same slope, negative 9 over 4, which is G. Okay. All right, 11 asks us, a DVD player with a list price of $100 is marked down 30%. If John gets an employee discount of 20% off the sale price, how much does John pay for the DVD player? So again, we're just going to do a percentage problem. We start with 100, which is easy when dealing with percents. So 100 times 70% times 0.7 is 70. So that's the first markdown. Then John gets a discount of 20% off of that price. So 70 times 0.8, because he's paying 80%. He gets 20% off. He's paying 80%. So you have 70 times 80% is $56. That's how much he pays. So that would be answer C. Now, a problem like this, you always want to make sure it doesn't ask you how much is taken off, how much does he save, because that would be a different number. They're asking how much does he pay. He pays $56. The answer is C. And 12 just asks us, we have square root of negative 9 squared. And they tell us I is the square root of negative 1. So what we're doing there is when we work that out, negative 9 squared, negative, is negative 81. So we'll pull that negative 1 out of the square root sign. They told us negative 1, the square root of negative 1 is I. So we'll pull that out. So we have I, and then we're just left with the square root of 81 in there, which is 9. So our answer becomes I times the square root of 81, or I times 9. which is F9I. Okay, so that is it for these two sets. What we'll do before Friday is the next quiz, which will be posted, and then we'll do the next two sets, so set 2 and set 3 for the assignment, and we'll go over those next on Friday at 6 o'clock. So on Friday at 6, we'll talk about geometry and just a little bit of trig, because there's only a little bit of trig on the ACT, and then we'll go over sets 3 and sets 4. Which you will have hopefully done by Friday. So Friday at 6, and then next week is Wednesday and Friday at 6. We'll do science, and then we'll finish up with writing the following Tuesday, the 27th. That will be our last session. So if you have any questions before Friday, please feel free to email me. We will send out a reminder this week about the next upcoming class. And if you have any questions, like always, please feel free to email me. Thank you so much, and I will meet you here Friday at 6 o'clock. Thank you.